This video kind of as a PSA and kind of to showcase these things. The PSA and the bottom line is that no joke, there's no way to discern these things. That's the bottom line that I'm going to show you, that there's no way to discern whether or not an image is AI created or whether or not it's like an actual image. The differentiation between the two at this point is identical. I just can't tell the difference. There's no way to detect telling the difference. And then so when you see some AI generators, a lot of AI generators now, they're putting a watermark on the AI generation itself. And then that's the only way to tell. Like if that watermark doesn't exist, then there's no way to tell on the image itself. And so showcasing exactly why. It's one thing to say these things, and it's another thing to dive into it. So let's dive into exactly this, and I'll showcase this so you can visualize this. And so what we're going to do is attempt to create a AI image creator detector in this instance. And then so we're going to use matplotlib, scipy, and scikit as our main packages for this. And then so we for the first thing, I'm defining essentially experiments and then how exactly I want to set this up. And then so I set this up and then I realize that I'm going to try to detect noise. So then first pass is to grayscale an image, and then we want to detect the high scale noise of the image, and then we want to flatten it and then reduce it. And then we want to check for high frequency noise, and then check for high frequency noise, saturation distribution, and edge consistency and diffusion detection. Are like that's kind of what I bundled together into diffusion detection. And then by doing that, I essentially create this algorithm and this output here, and then it gives us an output, and then we can see here in this instance it gives us an output, and then it will show us that in this instance that this one is unlikely to have a Gaussian potential diffusion generation. So it's detecting it that it's potential diffusion. And then no matter what I do with this generation and this first generation, like every image will show potential diffusion generation. And so I have two images that I created that I have here, my AI cat and then my cat .jpg. My AI cat is 100% diffusion because I generated it via ChatGPT, right, Dolly. And then my cat.jpg, I pulled it off of Google Images, and I pulled it from Britannica, like Britannica encyclopedia. And then so I figured like they're not using AI image, like generated images, but the more I go through this, like all of these exercises, the detectors that I run detect more aspects of this one being AI generated than my Dolly image, just flat out. And then when I look at this, at this point, I can't even tell you that my control image is not AI generated. And then so at this point, I have gone through these tests and gone through this testing and confused myself to the point where I can't even tell you the difference, right? And then so I've come up with, and then I consolidated all of this to this one main cell. And then I want to leave this as this one main cell as this notebook. And then the one main cell is pretty straightforward, right? You just load the images, and then it checks all of those same things. So it's checking for high frequency noise, entropy within the image, and then the high saturation, and then that edge consistency. And then we consolidate all of that, and we get essentially a vision score, and then so diffusion detection. And then in this instance, so again, this is our control image, right? This is the control image that is like not AI generated, quote unquote. And then it detects this one as 75% AI generated. And then no matter what I do, it keeps doing this. So I like at this point, I'm worried about my control image. And then so but so we can see here, like again, so high frequency noise, this is what it looks like. Sensor noise, this is what it looks like. Saturation, distribution, edge consistency. And then so it kind of goes through and then it tracks these things. And then let me show you, I'll update this for the AI cat. And I might have to go through and reconnect. I don't think so. There we go. And see my AI cat. So this is the one that I know 1,000,000% is AI generated. It gets a lower score. It's 50% probability that it's AI generated because so high frequency noise detected, sensor noise detected, but saturation distribution not detected, and edge consistency not detected. So, and then this is very clearly AI generated. And then, but it's not detecting it as is. But again, my quote unquote like my like image that I thought was real is coming out as 75% diffusion as opposed to 50% diffusion generated with my real one. So that's where we stand. And then just showcasing this for you. And then this is going through and then these are the best known methods, right? And these methods, they worked for a while, but the thing is so keeping in mind how you train image generation, right, is that image generators are designed to fool there's a predictor and a detector, right? And it's designed to fool the detector, and the detector will build out and be looking for things like this. It will look for high frequency noise, it will look for sensor noise, it'll look for saturation distribution, and it'll look for edge consistencies. And then so each generation of these image generation models is just naturally smoothing out these things anyway, and naturally removing these things as it goes through, because that's what it's doing as a GAN, right? And it's training each successful generation as a GAN, and then the generator is going to win out. And in that instance, just how it works, right? Given enough time, the generator is going to figure out what the detector is detecting, and then figure out how to avoid that. There you go. And then so now we're at the point where there's nothing to detect. Literally, as you can see here, if we break apart the images, right? Looking at the images and breaking them apart, there's nothing to actually detect the differences in these images from a scientific level. It's just literally eye test at this point. Eye test at this point is telling us that, I don't know, this image from Encyclopedia Britannica is 75% chance it's diffusion detected, because it's failing 3 of the standard tests for diffusion. So here you go. This is where we're at overall, right? Give me any image overall, and there's going to be these same type of tests. I won't be able to tell you. Give me the image of the president, of the Pope, images of political images, etc. There's no way, and there's nothing to. Their only enforcement is on the companies themselves, right? The companies that are putting in the actual watermarks themselves, and voluntary watermarking, literally voluntary watermarking is it. Without that, if it's that and going through the telltale signs of the image itself and looking for bad remnants in the image quality itself, right? The human detection quality, and human AI detectors are the last stand at this point, and they're kind of the last remnants, and even that is starting to fail. So here we are, and this is our reality. What to do about it? I don't know. Yes, I think it's definitely a problem. We should do something. I don't know, but here we are. If you like this type of content, please like and subscribe. Thank you very much.